going to give me some information. It's going to describe how well you did on the test. And not only will it describe the central tendency, the average, it's also going to tell me how far apart your scores are from that average. Okay, so that's the range, that's the variance, variability, standard deviation. Okay, so that's important as well. Did you have?
Oh, it's what's the difference between variance and range?
Yeah, okay, so quickly, so he asked what's the difference between variance and range. So range is really nothing mathematical. It's just this is the lowest score to the highest score. Okay. The variance is actually more, it doesn't really have a verbal description. It's actually the standard deviation squared. So when we get into calculating a standard deviation, which is a variability, right, we're going to calculate variance first, and then we're going to square root variance to get standard deviation. So it's more of a mathematical, you know, and it's used, though, it'll be used to talk about variability and range, but technically speaking, it's more mathematical. Okay. Okay. All right, so inferential steps. So, when we talk about, oh, I'm taking a statistics class, we really are referring to inferential steps, okay? Inferential, the base word is infer, so we're going to infer something about a variable that we're using to answer a question, right? So, these are techniques that allow us to study samples and then make generalizations about the populations from which they were selected. Okay, that's what we're talking about here. So when I was saying, okay, well, is this little bird representative of these? Or, you know, did this come from this nest? Or maybe this bird came from a different nest? Or maybe it's just this random bird kind of falling from out of the sky? So those are the types of questions. We have to infer, okay, where the sample came from. Okay, and so that's what we're doing. Okay, so we're, well, you know what? Let me give you an example. And I apologize. I know that this is sort of hard to see, so I'm going to talk about it too. So I apologize to those in the back. I'm going to turn this. So this is an example of a study, a research study. So we have descriptive in here, we have inferential, okay? So let's say that we want to compare two methods of studying, okay? So method A, we're going to look at students reading from printed pages, okay, like an actual textbook, and then students sample B is students who read from a computer screen, like your ebook, okay? And our question is, well, does the type of study method have an effect on test scores, okay? So in other words, when we test each group or each sample, does one do better than the next? Is there a difference, okay? There's that word, difference, right? So the first step is to use descriptive statistics, right? So we're going to organize and simplify and summarize our information. So instead of looking at each of these scores and kind of giving some idea, some kind of fuzzy idea of how well they scored on the test, their average score is 26. You figured out the mean. Here, for sample B, the computer screen people, they scored an average of 22 on the test. And keep in mind, this is the same test. Okay? So that's an example of using descriptive statistics. Now, we're looking at these differences. Okay, the word difference, there we go again. And is there a difference between these two groups on their test? Yes. So, can we say that yes, the type of study method, study method has an effect, that people who study directly from the printed page do better on tests than those who study from ebooks? Can we say that? There's a difference. Okay. We can technically say that, okay? However, in this sample only, we can say there is a difference because 22 is not 26, okay? It's pretty black and white. Statistics, there's something called error, okay? The sampling error, for example, so we're going to talk about in a minute, where it's possible, it's probable, okay, that there really is no statistical difference. So clearly there's a difference with the raw score, the raw average, but is it a real difference? Because if the sample of the students does not represent the population of college students, then there might really not be a difference, okay? And you guys are looking at this going, no, 22 and 26. Last time I checked, those are different, okay? But in statistics, we're looking at probability and not just yes or no, definite or not definite, okay? We're looking at, is it likely, is it probable that there are differences, okay? So we cannot make any claim about samples until we've run inferential stats. So means can show us that there's a difference. Great, there's a difference, but we don't know if there's something called a significant difference that makes sense, that's meaningful in relation to the study. Okay, so then that's when we jump into inferential stats. Now we're gonna include our test statistics, we're gonna include our hypothesis testing, and we're gonna find out if it's likely, more likely, that there is a difference. So when we use our inferential stats, okay, so there's a 4-point difference, right? But we're going to figure out if there's a possibility of two interpretations. One, there actually is no difference between the two studying methods, okay? The sample difference is due to chance, okay? So what I mean by chance is error. So we're going to talk about that a lot. We say it's due to chance, or a difference is due to chance, is due to error. So the reason why students scored higher reading from a printed page versus a computer page, there could be several reasons, okay? What might be a reason why those are different that has nothing to do with the type of studying they did? Okay, let's have someone who hasn't spoken yet today. Yes?
Could have been tired, which could have affected their scores.
Oh my gosh, yes. So maybe the students who read from the computer screen happened to be a little more tired that day. Can I control if you're tired? No, but I can still put you in a sample and have you do a test and run a research study. I can't control that. Okay, so when we have error, that means it's something that was out of our control. Things happen, right? You come to class, you just broke up with your boyfriend or girlfriend, okay? You're not going to be in the same state of mind as you normally are. You feel sick, not the same state of mind as you usually are, okay? So that might affect how well you do on a test. All right? So those are called confounding variables. That's error. Those are things that we just kind of, as people, we bring into our lives, right? So all the stuff that's happening with family or with friends or other classes or our health, etc. Okay, maybe it's raining, there's a rainstorm outside, that's affecting you. Maybe the temperature is too warm in the classroom, maybe that's affecting you. Okay, so all these things play into how well you do on your test. Okay, so if there's too much of that, then we can say that there is no real difference. Okay, that meaning that the method of studying doesn't have much to do with why these things are different. Okay, it's because of chance, something we can't control because of confounding variables. Okay. Or our second interpretation would be, woo, there really is a difference between the two methods, okay? And the sample data reflects that difference. So we're gonna run our inferential statistics, our procedures, and our hypothesis testing, but we're gonna find out if there is or isn't a statistical difference. If there is a statistical difference, great, that's really what we want, okay? That means that if there's a true difference, then we're going to be able to say our variable, which was the method of studying, does have an effect, okay? And it does seem to be better performance-wise to read, to study from a textbook. Okay, so we have those possible two interpretations. We go through all of this. So can you see how the descriptive stats plays a big role in our inferential stats? So, like I said, first we have to take all the data and organize it and make it like either into a chart or get the standard deviation and the mean, and then we can take the mean and that's what we compare. Okay. Any questions? Yes.
How can anything really be proven if there's so many factors that go into it?
That's a great question. First of all, I'm going to crunch the word proven, because in statistics, we're never going to prove anything, okay? Because of what you said, because of so many things that we don't have control over. The question is, okay, do we have a big enough sample size, all right? Do we have a sample that's pretty generalizable to the population, okay? Did we sample well and randomly? If we did those things, okay, then we might actually find that there is a real difference despite all of the other stuff, all of those factors that could influence the results, okay? But we're gonna have to, I wanna get that into our head that yes, everything we do with statistics, it's error ridden, okay? There's so much of that because you guys are people, because we're studying people in behavioral sciences. Okay, so lots of error, and that's really what we're trying to combat. Okay, we're using error, we're making sure that it's a part of our procedures, so that we can be more confident that we have a difference or not. Okay, so we have to keep that in mind. Right? Yes.
So safe to say that, like a statistics, stats that show like reliability. More reliable data?
So stats has more reliable data?
Yeah, it's like that's what you guys are looking for, right?
Well, we're talking about, okay, so not reliability is kind of like more of a measurement term. So if we ran the same study over and over and over and over, we came up with the same results, then we would say, well, this is more reliable. Okay, so yeah, that's one reason why we would look at statistics. It's not just an anomaly if we get a result in one group. Questions? Any more questions? Okay. So now what I want you to do wake up. All right, so you guys had some great questions about, well, there's so many factors that would be involved in making decisions about differences between groups. One of the issues that will haunt us the day we die is, or statistically die, is when a researcher does not select a sample that represents the entire population of data. So that's part of what sampling error is. Okay, we already know that. We've talked about that. So when that happens, then the results that we find in the sample do not represent the results that would be obtained from the population. So if we go back to the M&M example, right? So we're gonna draw M&Ms out of the bag. We don't know what kind of M&Ms are in the bag. So we're just gonna close our eyes, grab M&Ms, and look at the M&Ms, and we're gonna assume that those M&Ms are very similar to the ones that are in the bag. They may or may not be. Okay. So again, we want the sample to represent the entire population. If it doesn't, then we're going to run into some problems. Another way of talking about sampling error is it's just m minus mu. So it's that difference between the statistic and the parameters. Okay? So if, say, in our population of marbles, we have, 50 marbles. I'm sorry, M&Ms. We have M&Ms. Then when we take out a certain amount of M&Ms, okay, is there a difference in representation? We take out all blue ones. Yeah, there's going to be a difference. There's your difference, M minus mu. Okay. Okay, so knowing about sampling error, knowing about descriptives, knowing about inferential stats, what I'd like you to do, you can do this on your own. You can do this with someone else. You can even go crazy and find someone else you don't know to work with. I'm going to give you about 5 to 7 minutes, and I'd like you to come up with a research question, and let me help you do that. So just like when we were looking at the study methods, okay? So my question as a researcher would have been, does type of study method have an effect on test performance? Okay, so your research question, something like this, does variable, okay, have an effect on this variable, okay? By the way, if I say research methods, is that my independent variable or my dependent variable? So my independent variable, we'll get to that on Thursday in more depth, have an effect on something that's measured, which would be our dependent variable. So if you think about those, that example, okay, about the method studies of methods of study. So first thing I want you to think about question, okay? Does blank, this variable